Assalamu alaikum. Welcome back to another video. I hope you all are doing well. Today we are going to have a brief introduction of H-Bridge project. That what is a H-Bridge and why we use H-Bridge, as H-Bridge is our semester project submitted to Professor Umar Farouk and Engineer Muzammil Ghaffar, submitted by these three role IDs. Moving to our project topic. The topic of our project is H-Bridge, the abstract. The first thing that we are going to discuss here is the abstract. This report documents the research of H-Bridge, a motor direction control circuit. The goal of this project is to understand the BJT's based circuit by reflecting upon the different aspects of this circuit, as to how the circuit is working and how it is responding in different situations. The controlling motor, the components used in the circuit as well as their values will also be able of great interest. By making this report, we endeavor the understand we are able to understand the application of H-bridge circuit as well as understand the working of this circuit. Furthermore, in order to complete this circuit, some resistors, batteries, optocouplers, and of course bipolar junction transistors will be required. Here the bipolar junction transistor is used as a switch. In this report, we will also be reflecting upon the applications and uses of this H-bridge circuit. Introduction. A H-bridge is an electronic circuit that switches the polarity of an voltage applied to a load. This circuit are often used in robotics and other applications to allow DC motor to run forward or backward. Here is the most basic diagram of this circuit. By this configuration, this is called as an H-bridge. Here the flow of current is shown, that if we want to move our motor in clockwise direction, so this is the path. Here the switch 1 and switch 4 is closed and switch 2 and switch 3 are open, and to move the same motor using the same circuit in counterclockwise direction, the switch 2 and switch 3 is in closed state and the switch 1 and switch 4 is now open. Moving next to our background and motivation of this project. So here we have discussed the H-bridge circuit with BJTs has gained significant popularity and widespread use due to its ability to control the direction and speed of motors. It has become a fundamental component in many electronic systems, particularly in robotics and electronic vehicles. The background and motivation behind the development and use of H-bridge using BJTs can be attributed to several factors. These factors are: first, motor control, that we are going to control the motor in forward and backward direction, use the motor more precisely, control the speed also. The second one is robotics, that we are going to use this circuit in robotics by using this circuit using Arduino, using microcontrollers more and more, and then we also use this in electrical vehicles. Moving next to sustainable development goals of our circuit, H-bridge are often used in power electronics and control systems, including renewable energy applications such as solar and wind power. By efficiently converting and controlling electrical energy, H-bridge can support the generation, distribution, and utilization of affordable and clean energy sources. H-bridges play a crucial role in the development of advanced control systems and automatic technologies. They enable precise control of motors, actuators, and other devices, contributing to the enhancement of industrial process, transportation systems, and infrastructure. Here we have the problem statement of our circuit. One significant problem is the inefficient control of H-bridge circuits. These circuits consist of four switches that can be turned on and off in different combinations to control the direction and magnitude of flow of current. Inaccurate or imprecise control signals can lead to suboptimal operations, resulting in reduced efficiency and performance of the controlled devices or systems. Inadequate control can also cause issues such as excessive heat generation, noise, and even device failure. Furthermore, H-bridge circuit may face challenges related to voltage and current ratings. In high power applications where large amounts of current or voltage are involved, H-bridge must be designed and configured to handle these levels without compromising safety or performance. Overloading and mismatched rating can result in device failure, overheating, and potential hazards. Here we have the objective of the project. The objective of the project is to design an H-bridge using BJTs or FETs to control the direction of a motor, optical isolation and flow. Using optical isolation, using flyback diodes, use 9-volt battery, 9-volt source, and draw a maximum of 2 ampere current. The motor is to operate continuously for 15 minutes to check that the paths are of good size, that they are able to flow current of 2 amperes for 15 minutes at least. Here is the cost analysis of the whole project is like cost about 1000 of each PCB. The description of the project is here. The H-bridge circuit allows the current to flow either in both directions. In whatever direction we are going to move our circuit or our motor, we are able. By press forward button, the motor will start moving in forward direction, and by pressing the reverse button, the motor is going to move in the reverse direction. I also going to upload the video clips of our circuit, that our circuit is properly working. A video is also attached or uploaded in my YouTube channel, and the link was also uploaded of this video and the other video also, that there we have tested all the circuits, the circuit that we implemented on breadboard and the circuit that we have made on PCB. So moving next to the timeline of the project, the H-bridge concept and its application have evolved over several decades. Here is a rough timeline highlighting significant milestones and developments related to H-bridge circuits. So basically in 1960 the H-bridge circuit topology is initially developed, and in 1970 there are furthermore advancements held in this circuit, and moving next in 1980 1990 there are many developments that is done. Moving next in 2000, the integration of an advanced control algorithm and digital signal processing techniques with H-bridge circuit allows for more precise control and motion profiles. Motor control system with closed loop feedback and sensorless operations become more common. In 2010, there are furthermore more applications added and more developments are done. And in 2020, ongoing research focuses on improving the efficiency and reliability of H-bridge circuit, reducing energy losses during switching transitions and enhancing control algorithms for various applications. The timeline mentioned here provides a general overview of the evolution of H-bridge circuit, but it's important to note that the advancements and developments in this field have occurred gradually over time with continuous improvement and refinement in design, control techniques and component technologies. Now, moving towards the methodology. As our report of this project is on the template of FYP project report means final year project report. So we have discussed about all the factors that we are we are discussing in our FYP reports. So here we are going to discuss about the methodology of this project. Building an H bridge using bipolar junction transistors involves designing and connecting the transistors and other necessary components to achieve bidirectional current control. Here is a step-by-step methodology by constructing an H-bridge for constructing an H-bridge with BJTs. Here first we have to select the components that what components are required what and what are the best components that we have selected for our project. Then determine power supply, that how much voltage is required to run this circuit. Then design the control circuit, means a control circuit in which of some isolations, some safety and some switches are connected. Then connect the transistors, connect the transistors in such a way that they are act like switch and also they are able to move the motor in both their directions. Add protection diodes also. Implement gate resistors also. Then moving next, connect control signals. Implement current sensing. Test and debug means before connecting the load, thoroughly test and debug the H-bridge circuit. Then connect load and finalize circuit. Connect the load such as motor or autorouter to the H-bridge circuit. Ensure that the load is within the rated specifications. Then implement safety measures. And at the end, it is important to note that the specific design and methodology can vary depending on the application's requirement, transistor types, and other relevant literature. For detailed guidance and best practice when constructing an H-bridge with BJTs. Here we have the list of our components that we have selected and then implemented. We use tip 107 PNP transistor, tip 120 NPN transistor, resistors of different values like 10K, 1K and 470 ohm, a PC817 optocouplers. An optocoupler is used for isolation purpose. The construction of an optocoupler includes an LED and a transistor. When the current flows, the LED on and transmit an optical signal of IB to the transistor at its base, and the transistor come in on state, and then further it further allows the circuit to work. Moving next, we use diodes. Diodes 1N4007 is a silicon rectifier diode. A silicon diode is a semiconductor having a positive and negative polarity. Then we used a DC motor, a battery of 12 volt 2 ampere, a container consisting of one or more cells in which chemical energy is converted into electrical and used as a source of power. Then moving next to the Proteus simulations. Here the main course come. Here is the Proteus simulations. This is enable pin. This is a switch to move. If this switch is in on state, the motor will move in counterclockwise direction, and if this switch is in on state and this switch is in off state, then the motor will move in clockwise direction, and if both the switches in on state or both in off state, the motor is not able to move. We used PC817 optocoupler. So now we are going to discuss that how our circuit works. As we on this switch, the current of 5 volt is transmitted from here to here, and this LED on and transmit an optical signal IB to here at the base, and this transistor is in on state, and then it allows this circuit to work, and then a 12 volt DCC DC is applied here, and the current is flow from here, from this path towards the motor. As you can see that this wires move here to this optocoupler, and the same process is done. This LED is on and transmit a signal of IB at the base of this transistor, and this transistor is in on state, and this part of the circuit works. Then the current is flow from here to this and this direction and move the motor in clockwise direction, and then move from here and ground it. And if we on this switch and off this, then the current or the 5 voltage is applied here and also here. Then both the optocouplers are in on state, and in this part of the circuit and this part of the circuit is in on state. The current will flow in this path, and the motor move in counterclockwise direction, and the current is then grounded from this side. Here we used uh, capacitor and also these diodes are for safety purpose, like we use these diodes for back EMF. Optocouplers are used for isolation process, and here we have the full circuit which is properly working. Then moving next towards the working of our project. This circuit is designed to control the direction of motor by pressing the forward button. If we press forward button, the motor is start moving in forward direction, and if we press the reverse button, the motor is start moving in reverse direction. If we press forward button, the top left PNP and bottom right NPN transistor is in on state, and if we press reverse button, the top right PNP transistor and bottom left NPN transistor is in on state, and then in both processes, when top left and bottom right transistor is in on state, the motor is moving forward direction, and when the top right and bottom left transistor is on state, the motor move in backward direction. The PC817, when turned on, it allows the BJT 107 and 120 to rotate the motor. If the PC817 is in off state, the circuit is not going to work at all. Enable button also provide a privilege to turn off and on the motor by closing and opening the switch. Here is the datasheet of both the transistors. All the values are given here, and We also select the step transistor by studying the datasheet of these transistors and check that the results of these transistors are exceptional. These transistors works exceptionally, very good results. Here we have discussed that if we replace PNP transistor with NPN, we cannot use NPN transistor instead of PNP transistor, because as we know, to make circuit flow through the base of transistor, we need to make the voltage on the base about 0.7 volts higher than emitter. So if the emitter is not connected to ground, and if there is some load between emitter and ground, so we would have to drive the base to a much higher voltage in order for the transistor to conduct the power to load. Since the voltage across the load can vary, so you can never be sure just how much voltage to put on the base to make the transistor conduct. Furthermore, you are also never be sure just how far you are turned the transistor on. On the other hand, the PNP transistor allows the current to enter from emitter, give some current to base to turn on the base, and give the remaining current to collector to turn on the load. Moving next again towards the components, here we have explained the, briefly about how these components playing role in our circuit. Here we have discussed about PC817, also about the about the resistors, diodes. Moving next towards the mathematical modeling. To analyze the behavior of an H-bridge circuit with BJTs mathematically, we can consider a simplified model. Here is a general approach to obtaining a mathematical model for an H-bridge using BJTs. Identifying the BJT transistor characteristics begins by determining the electrical characteristics of the specific BJT. Moving next, analyze individual transistor operation. That please check your transistors individually, that how they are working. Determine the load model. The load model, like which type of load you are using, a motor and a LED or something like these. Establish control signals, like you have to establish some control signals, that when you provide these signals the specific work is done. Then formulate switching equation. Then moving next, derived circuit equation, and then using Kirchhoff laws the switching equation derives these equations, and then simplify and linearize equations, solve the equations, and validate the model. At last, it's important to note that the mathematical modeling process can vary depending on the specific circuit configuration, load characteristics, and transistor models used. Additionally, the complexity of the model may increase if more advanced effects such as switching losses and parasitic elements need to be considered. Moving next, that first we have used a breadboard to test our circuit. Here we use a breadboard, some jumper wires, and all the components that we have discussed before. Here we have the pictures of our implementation of the circuit on breadboard. The circuit is working properly. We are also going to upload another video in which we have uh, compile all the videos, all the working videos of our PCB and also our breadboard, and also explain some more things in that video. We are also going to upload the link of this video also, and this and these both videos is enough of for this project, as the detail of all the components and all the simulations, all the PCB designs, and all the implementations are also explained to you all guys. The circuit is perfectly working on breadboard, and testing video link is uploaded on GCR. PCB. A PCB is a printed circuit board. It is a plastic board or a, no, a board which is made of non-conductive material, and a conductive lines are printed or etched on this component that we required in designing this project is a PCB sheet, some soldering wire, a solder, a FeCl3 chemical, and that's all, and the components that we have discussed before. Here we have the PCB layout of our circuit. I hope you guys like this. This is a very much precise circuit, and this circuit is working properly. Here is the 3D view of this circuit. Check this. Here we have implemented the circuit of H-bridge using the same H-bridge circuit using Arduino Uno, that we have made a test bench and then tested this circuit using Arduino Uno. Specifications of this project. The specification of these projects include voltage rating, current handling capability, power dissipation, and etc. Moving next, that how we are able to make a PCB. These require some process like printing process, etching process, drilling process, soldering process, and at the end our PCB is ready for testing. So here our final PCB that we have implemented and tested, and our testing video is also uploaded. So at the end we are going to discuss about the applications. It is most commonly used to control and replace the DC motor rotation direction. H-bridge is also used in many other applications such as DC to AC, AC to AC, or DC to DC converters. The H-bridge circuit reminds of the letter H, and that is how it is gotten its name. The main advantage of using an H-bridge driver are high efficiency, rotation direction change, and braking the motor. So that's the end, and that's all for today's video, and I think there are no further explanation needed for this project. And if you have any query, any question, or want to ask me to do some more modifications in this project, you may ask me in the comment section. Thank you for watching this video, and I hope if you have understand, then please comment, and if you are not understanding that what is the project, so please then also comment and ask me to explain you these points that you have not understood. Thank you for watching this video. Hope to meet you guys in another video. So for this today, Allah Hafiz, and again thank you.